Welcome everyone. In this lesson video, our topic is inverse of a matrix. On the board, I have the question, given the matrices X and Y, find the inverse of Y and then X. X is a 3 by 3 matrix, while Y is a 2 by 2 matrix. Now on your screen, you will see the process of finding the inverse of a 2 by 2 matrix. Now, to implement the process, the first thing we are going to do is to find the determinant of the matrix. Anytime you are asked to find the inverse of any matrix, you need to first of all find the determinant. The essence is simple. If you find the determinant and it's not zero, you can proceed with other steps. But if you find the determinant and it gives you zero, it means that matrix has no inverse. That is, it is not invertible. Now, let's find the determinant of Y. There is a lesson video on transpose and determinant of a matrix. That lesson video is specifically on 2 by 2 matrix. If you have not watched that video or you don't know how to find the determinant of a 2 by 2 matrix, I will advise you to go watch that video so that you can understand what I'm going to do in finding the determinant of Y. Now, going ahead, the determinant of Y will give me the product of the leading diagonal, which is 2 times 9 minus the product of the other diagonal. And this will give me 18 minus 15, and that will give me 3. So now that the determinant is 3, it means Y has an inverse. Because as long as it's not 0, go ahead and find the inverse. So Y has an inverse. Now, the second thing you do is you interchange the elements of the leading diagonal, which is this one. You interchange the elements of the leading diagonal. So interchanging it, I will have 9 up, 2 down. And then the next thing is multiply the elements of the other diagonal by minus 1. And if you do that, you will have minus 1 times 5 will give you minus 5. Minus 1 times 3 will give you minus 3. That is what you will have. So the matrix I have on the board, this resulting matrix times, so the inverse of Y is equals to this, the inverse of the determinant times the resulting matrix. So our final answer is this. Or if you don't want to leave it like this, you can rewrite it in this form. 3 divide 9 will give us 3. 3 divide minus 5 will give you minus 5 over 3. 3 divide minus 3 will give you minus 1. 3 divide 2 will give you 2 over 3. So if you don't leave it like this, you leave it like this. And If you don't want to leave it in fraction, you can leave it in decimal. You can go ahead, find the decimal equivalent of the fractions in the matrix. So this is our final answer. Now let me go through the process again. I said the first step is you find the determinant of the 2 by 2 matrix. And we found 3 as the answer, the determinant. Because it's 3, it's not 0, it means we can go ahead that y has an inverse. Then the next thing is interchange the elements of the leading diagonal, 2 and 9, which we interchanged and we got 9 and 2. Then use -1 to multiply the other diagonal, which is this one, which is 5 and 3. And if you use -1 to multiply them, you have -5 and -3. Now, this resulting matrix, multiply it by the inverse of the determinant. And that is what you have as the final. So if you don't leave it like this, you can leave it this way. That is for 2 by 2 matrix. To find the inverse of a 3 by 3 matrix, we need to find the determinant. If the determinant is not 0, then we'll go ahead. It means the matrix has an inverse. Now, if you have not watched the video on finding determinants of a 3 by 3 matrix, I will advise you to go and watch that video first. That is a prerequisite to this lesson. Now, using Saru's rule, increasing this to 3 by 5, and then finding the products of the leading diagonals. This is the leading diagonals, the 3 of them. Then minus the product of the other diagonals, which is this, this, and this. Okay, the first group, I have 3 plus 6 plus, this time this will give you 12. 12 times 4 will give us 48 minus the other 3. This will give us 4. 36, 6. Now, if you add this group, it will give you 57 minus, this will give you 46. And the final answer is 11. So the determinant of this 3 by 3 matrix is 11. That means it has an inverse. Now, the second thing after finding the determinant of the matrix is we'll find what we'll call matrix of the minus. What do you mean by matrix of the minus? For each of these elements, anyone will take up, will remove corresponding elements in the same row and column, and then find the determinant of the resulting 2 by 2 matrix. That is what we mean by matrix of the minus. So this is how it goes. Now, if I'm considering the first row now, the first element there is 3. So if I'm considering 3, I will remove every element in the same row and column, and what I will have left is 1, 3, 4, 1. So that minor matrix, finding the determinant, I will have 1 times 1 minus 4 times 3. Considering this, I will remove the first row and the middle column. I will have that left. So that will give me 3 times 1 minus 3 times 1 plus, considering this, I will remove the first row and the last column. I will have this minor matrix left, and the determinant is 3 times 4 minus 1 times 1. That's for the first row. Going down to second row, the first element there is 3. So if I'm considering 3, I will remove the first column and the middle row. What I have left is 1, 2, 3, 4. So the determinant will be 2 times 1 minus 4 times 4. Minus in front of it, plus, I will explain the reason for this minus and plus, minus, plus at the end of this. So the second one, if I'm considering this one, I will remove the second column and the middle row. So I will have left 3 times 1 minus 1 times 4. Then, considering this, I will remove this and this. I will have 3, 2, 1, 4 left. So the determinant will be 3 times 4 minus 1 times 2. Then, considering the last row, the first element there, I will now remove the first column and the last row. I will have this minor matrix left. So it will give me, the determinant will be 2 times 3 minus 1 times 4. Then, considering this, I will remove the middle column and the last row. I will have 3, 4, 3, 3. So the determinant is 3 times 3 minus 3 times 4. And then the last one, considering this, I will remove the last column, the last row. So what I will have is 3, 2, 3, 1. So the determinant is 3 times 1 minus 3 times 2. Okay, having done all this, I will now come up with a matrix, which I call matrix of the minus. So each group will produce an element. Each group like this will produce an element one by one. So considering the first group, I have 1 times 1 minus 4 times 3. This will produce 1, this will produce 12. So 1 minus 12 will give me minus 11. Going to this one, this is 3 minus 3. That will give me 0. So 0. 0 is neither negative or positive. Then this one, this will give me 12. This one will give me 1. So 12 minus 1 will give me 11. Going to the second line, I have 2 times 1, which will give me 2. This one will give me 16. 2 minus 16 will give me minus 14. But because of minus in front, I will come up with just 14. This will give me 3. This will give me 4. 3 minus 4 will give you minus 1. This will give me 12. This will give me minus 2. 12 minus 2 will give me 10. But because of minus outside, it will give me minus 10. Then this will give us 6. This will give us 4. 6 minus 4 will give you 2. This will give us 9. This will give us 12. 9 minus 12 will give you minus 3. Because of minus in front, come out as 3. Then lastly, 3 times 1 will give you 3. This will give you 6. 3 minus 6 will give you minus 3. So this is what I call matrix of the minus. Now, this is the second step. The third step is you find the transpose of this matrix of the minus. And the transpose simply means interchanging the rows and the columns. Now, interchanging it, so the transpose will give you this first row will come out as column. So it will now be minus 11, 0, 11. The second row will come out as the second column. 14 minus 1 minus 10. Then the third row will come out as the third column. 2, 3 minus 3. So this is the transpose of this. Then finally, for our final answer, what we are going to write down is we are going to use the determinant to divide this transpose. We are going to use the determinant, which is 11, to divide this transpose. That's the last thing we are going to do in order to have our final answer. Now, having found the transpose of the matrix of the minor, the next thing we are going to do is to write our final answer. This transpose is also called adjugate. So you can say adjugate of the matrix X is minus 11, 14, 2, 0, minus 1, 3, 11, minus 10, minus 3. Now, for the inverse of X, it is using the determinant to divide each of these. So if you like, you can write it like this. So this becomes our final answer. Or you use determinant to divide each and every one of them. And it will give you, this will give you minus 1, 14 over 11, 2 over 11, 0 minus 1 over 11, 3 over 11, 1 minus 10 over 11 minus 3 over 11. So either you leave the answer like this or you leave the answer this way. Or better still, you can convert these fractions into decimal equivalent, and that becomes your final answer. So in 3 by 3 matrix, in finding the inverse of a 3 by 3 matrix, first of all, find the determinant, which we did here, and we found 11. After finding the determinant, the next thing is the matrix of the minus. And that's what I did here. This is the matrix of the minus. And then, for this minus, plus, minus, plus, minus, and the rest of them, in matrix of the minus, because this is, the question is 3 by 3 matrix, we'll consider this. That's what we'll consider. In finding the matrix of the minus, we'll use this sign allocation in order to find the matrix of the minus. So when you are considering the first element, the resulting minor matrix will have a positive sign in front of it. When you are considering the second element of the first row, the resulting matrix will have a minus sign in front of it. So with this, you can fix the signs. So for the first one is plus, that's this one. The second one is this minus here. The third one is this. Then coming down to the second row, I have minus for this group, then plus for this group, minus for this group. Then coming down to the last one, plus for this group, minus for this group, and plus for the last group. So you need to consider this arrangement, this sign arrangement, in computing matrix of the minus in order to come up with this as your result. And after coming up with this, the next thing is to transpose it. Transpose this resulting matrix of the minus, and it gives you this, which we'll call the adjugate of x. So the transpose of this matrix of the minus is what we call adjugate. Then for your final answer, the inverse of x is using the determinant to divide each of the elements. So either you leave it like this without doing the actual division, or you do the actual division and have this, or you can decide to leave them, all these fractions, in decimal. Thank you for watching inverse of the video on inverse of a matrix, and bye for now.